Firstly, when you talk about the sine, cos, tan, if you reciprocate them, the first thing is that if you reciprocate sine, which is 1 over sine theta, that is cosec theta. So while you're doing the identities, in place of cosec theta, you can just write down 1 over sine theta. If you have second ratio is called as reciprocal of cos theta, which is sec theta. Third one is reciprocal of tan, which is 1 over tan theta is cot theta. So these three are some of the very basic stuff. So in case if you get cosec, I can write down 1 over sine. If I get sec, I can write down 1 over cos. If I get cot, I can write down 1 over tan. Now, the basic another basic ratio, the tan theta is also written as sine theta or cos theta. So wherever tan you can see, you can write on sine theta or cos theta. And wherever you see cot theta, which is also reciprocal of tan, which is 1 over tan theta as I've written here. So you can see that this can be written as cos theta over sine theta. So these are the parent identities, I would say. Now coming back to some of the derived identities, that is sine squared theta plus cos squared theta for an angle is 1. So wherever you notice that, wherever you have, for example, if I take sine 30 is half. If you take cos 30, it's square root of over 3 or 2. Like obviously you can calculate using calculator or unit circle. Now when you find out sine squared 30 plus cos squared 30, now you'll notice that it is nothing but half squared plus root 3 over 2 the whole squared, which is 1/4 plus 3/4, and that's equals to 1. So this is just a verification that if you take any angle, find the sine of that, square that ratio, add to cos of that same angle, and square that, the answer is going to be 1. So this is the first identity, and the second one is not cosec square theta. So these are the three different identities. I would just like to prove this one. I'm going to take LHS for this first one. So 1 plus, instead of tan squared theta, if I take sine squared theta over cos squared theta. Now since it is tan is nothing but you can see sine over cos, tan squared, sine squared over cos squared. Now if I take LCM of this, I get cos squared theta plus sine squared theta over cos squared theta. Now cos squared theta plus sine squared theta is 1 since we know here. So it is 1 over cos squared theta, and that is nothing but cosec squared theta. So sec squared theta. So that's your sec squared theta proof here. Now second one is 1 plus cot squared theta is cosec squared theta. So if I take 1 plus, instead of cot, if I take cos theta over sine theta, so cos squared theta over sine squared theta, you take LCM of this, it is going to be sine squared theta plus cos squared theta over sine squared theta. So this is my left hand side, and you take this, will be 1 over sine squared theta, which is equals to cosec squared theta. So for the first one, you take LHS, you expand this. So cos squared theta plus sine squared theta plus 2 sine theta cos theta. And this one is cos squared theta plus sine squared theta minus 2 sine theta cos theta. So this get cancelled, and you get cos squared theta plus sine squared theta is 1. Cos squared theta plus sine squared theta is 1. So you get 1 plus 1 is 2. Since you get this 2, and hence you prove the identity. Just here, so LHS that is 1 minus cos theta and 1 plus 1 over cos theta. Take the LCM of this. So 1 minus cos theta, and you take LCM of this will be cos theta plus 1 over cos theta. Now this is like 1 minus cos theta, 1 plus cos theta over cos theta. Now remember that this sometimes students make mistake like, okay, 3 times 7 or 4, they take LCM of this. This is a multiplier, right? So you can just multiply 3 with 7. This 21 over 4. This is not, you're not going to take separate cos theta here. So
Or I did multiplied the two brackets.
yeah, no. So now here what you do is you simply take 1 minus cos theta, 1 plus cos theta. You open the bracket. So it's like a minus b. So that's a minus b, and this is a plus b. So that's
So you can make
a squared minus b squared. So when you do a squared minus b squared, what we get is 1 minus cos squared, 1 squared minus cos squared theta over cos theta. So this is 1 minus cos squared theta is nothing but sine squared theta over cos theta. So now what you do is you break sine squared theta in two parts. It is sine theta times sine theta over cos theta. I can break this up. And remember this once again, it's a product. So you don't need to divide. You don't need to give this denominator to both. So it's sine theta over cos theta is tan theta times sine theta. So that's how you prove the first one. That's tan theta times sine theta. So for the h part, we take the LHS. That's your sine theta. That's your sine theta over 1 plus cos theta plus 1 plus cos theta over sine theta. So if you take LCM of this, what we get is sine theta 1 plus cos theta. And in numerator, you're going to get sine squared theta plus 1 plus cos theta the whole square. So what I actually did is I multiply this one by sine theta, divide by sine theta, and multiply this by 1 plus cos theta and 1 plus cos theta here. So you get this expression because denominator is same here. So now you open the bracket, so you get sine squared theta plus 1 plus cos squared theta plus 2 cos theta using a plus b the whole expansion. You get sine theta 1 plus cos theta. Now here what we get is sine squared theta plus cos squared theta is 1. So 1 plus 1 plus 2 cos theta and times sine theta 1 plus cos theta. So this becomes 2 plus 2 cos theta over sine theta times 1 plus cos theta. So you take 2 common. So what you get is 1 plus cos theta over sine theta, 1 plus cos theta. So what you get is 1 plus cos theta get cancelled. And at the end, what you get is 2 cosec theta. So that's what you wanted to prove. That's what you wanted to prove the right hand side. So I'm just taking the J now for the explanation. So let's first left hand side is 1 minus sine theta plus 1 plus sine theta. And we have to prove that this equals to 2 sec squared theta. So take LCM. What we have to prove is 2 sec squared theta. So take LCM, the left hand side first, and take LCM. So 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Take LCM for this. So if you take LCM, it becomes 1 minus sine theta, 1 plus sine theta is the common denominator, and the numerator is going to become 1 plus cos, 1 plus sine theta, because you multiply this thing by 1 plus sine theta, divide by 1 plus sine theta. Here is 1 plus sine theta, and 1 plus, you multiply with 1 minus sine theta, and divide by 1 minus sine theta. So here we get is 1 minus sine theta. This get cancelled, and you get 2 in the numerator over 1 minus sine squared theta. Because like a minus b, a plus b become that. So it's 2 over cos squared theta, and that is nothing but 2 sec squared theta. How I got 1 minus sine squared theta is cos squared theta. If I bring sine squared theta this side, you get cos squared theta is 1 minus sine squared theta. So wherever you have 1 minus sine squared theta, you can put cos squared theta, or wherever you have got 1 minus cos squared theta, you can put sine squared theta. So that's how you do basically this kind of proof. So for the f part, what we do is cos theta over 1 minus sine theta, that's a left hand side. Now in this case, you can see that there is no possibility of going ahead. So somehow I have to use the identities that I've learned here. So what I do is I am just going to multiply this with 1 plus sine theta, and this with 1 plus, divide also by 1 plus sine theta. Now as a result of this, what happens is in the denominator, what we get is we get 1 minus sine theta, 1 plus sine theta, and the numerator what we get is cos theta in bracket 1 plus sine theta. Now, if you simplify this, you get cos theta 1 plus sine theta over 1 minus sine squared theta, because a minus b, a plus b. And now after this, what we do is we take 1 minus sine squared theta as cos squared theta, cos theta 1 plus sine theta. You simplify this, and this become 1 plus sine theta over cos theta. And if you isolate these, 1 over cos theta plus sine theta over cos theta. So 1 over cos theta is sec theta, plus tan theta. So that's how you get this proof. Now for part D, what we do is you're going to take the left hand side. So left hand side is 1 plus 1 over sine theta times sine theta minus sine squared theta. And we need to prove that this equals to cos squared theta. So take LCM, that is nothing but sine theta plus 1. So 1 plus sine theta over sine theta. That's going to be LCM, because if I multiply this by sine theta divided by sine theta times, if you take sine theta minus sine squared theta as it is here. Next step is take sine theta common from the second bracket, if you see. So if I take sine theta common, what you get is 1 minus sine theta. So this sine theta can be cancelled out, and you get 1 plus sine theta times 1 minus sine theta. So that is nothing but 1 minus sine squared theta, which is cos squared theta. So that's how you prove the right hand side and left hand side they are equal. Now for G part, what we do is we take left hand side. So it is cos alpha over 1 minus tan alpha plus sine alpha over 1 minus cot alpha equals to sine alpha plus cos alpha. Now what I'm going to do is I'm going to first take LHS here. So my LHS is cos alpha over 1 minus tan alpha plus sine alpha over 1 minus cot alpha. Now, as we know that the tan alpha can be written as sine over cos, and so just try to just generalize the strategy, as that wherever you have tan and cot, you just try to write down them in terms of sine and cos. That makes life much more easier. So tan alpha is sine alpha over cos alpha, and cot alpha is cos alpha over sine alpha. Now, when you do this, what you get is cos alpha over 1 minus tan alpha is nothing but sine alpha over cos alpha plus sine alpha over 1 minus cos alpha over sine alpha. Now take the LCM for the denominator first. So I'm just going to show you here. So multiply by cos alpha, divide by cos alpha. This one you multiply by sine alpha and divide by sine alpha. So you're just taking individual denominator and first taking LCM of them. So cos alpha divided by cos alpha minus sine alpha divided by cos alpha plus sine alpha divided by sine alpha minus cos alpha divided by sine alpha. Now, what you notice is that if you have a number divided by a fraction, what happens is that if you're dividing like a divided by bc, b by c, if you convert this into multiplication sign, it'll become a times c over b. So this flips. So the answer is ac over b. So here that's what is happening. So this cos alpha goes up. So it'll become cos squared alpha over cos alpha minus sine alpha plus, if this part goes up and becomes sine squared alpha over sine alpha minus cos alpha. Now when you notice here, actually cos alpha minus sine alpha, they're the same stuff. Here also the same thing. So if you want to take LCM, they are just opposite sign. They're just in opposite sign. So what I can do is, if I can take just negative common, so if I take negative common from the denominator, let's say cos alpha minus sine alpha, let it be as it is, plus sine squared alpha over, if I take negative common, this negative 1 common basically from cos alpha minus sine alpha, this is what it's going to become. And then if I multiply plus and minus, it becomes cos squared alpha minus sine squared alpha over cos alpha minus sine alpha. So this is the main key step out here, because this positive and this negative multiply to negative 1, and then denominators are common, and so you just subtract the numerator. Now after this, the key step is the factorization step. So what you do is you factor this out. So cos square alpha minus sine square alpha is cos alpha minus sine alpha plus cos into cos alpha plus sine alpha over cos alpha minus sine alpha. So what happens is this cancel, and you get the answer as cos alpha plus sine alpha, which is the right hand side. So that's what you wanted to prove. So for the fourth one, what we got to do is we got to first take square the bracket, open the bracket. So the left hand side is sine theta plus cos theta. We got to show that this whole squared, and we got to show that this equals to 1 plus 2 sine theta cos theta. So you expand the brackets. So that's a squared plus b squared plus 2ab So sine squared plus cos squared is 1. So that's how I get the proof. That's the first part. Now they said that find the possible value of sine theta plus cos theta if they have given the product of sine and cos is 7 over 18. So product of sine and cos is 7 over 18. So we're going to just put this value out here, 7 over 18 out here. So we get sine theta plus cos theta, the whole squared is 1 plus 2 times 7 over 18. So that's equals to 1 plus 14 over 18 if you take LCM. This is 7 over 9. So you take LCM of this is 16 over 9. And sine theta plus cos theta is then plus minus 4 over 3. So these are the possible values of sine theta plus cos theta.